Hey, this is Sam from Shure. In this video tutorial, I'll talk about channel-to-intermod spacings and how to ignore them when coordinating frequencies to get more frequencies on air. If you're coordinating frequencies in Wireless Workbench for either Shure systems or third-party systems, you'll take advantage of the pre-built equipment and compatibility profiles that Wireless Workbench offers. Now, I've heard from a lot of people they feel that the equipment profiles that we predefine, basically that specify how much space each type of frequency takes up, they might be a little bit conservative. What this results in is the inability to get large numbers of frequencies when calculating using Workbench. What I'm going to show you is a set of tools that we've built in. They're a little bit more advanced, and you have to use some caution when using them. But if you use them appropriately in the right context, you can get more frequencies on air and get the output of coordination like you might from other third-party calculation software applications. So what I've got in my coordination workspace are some frequencies for a Telex BTR-800 intercom system. I've got a base station and a belt pack frequency, and I've also got the automatically calculate backup frequencies feature on. What that feature does is it will find the frequencies I've asked for, and then after that, find as many additional extra frequencies as I can. And I'm going to use that number of extra frequencies it finds to show you how making some changes will result in more frequencies. So if you're familiar with this BTR-800 system, it's an oldie but a goodie, a pretty common intercom system used in the industry today. But frequencies of this type of system tend to take up a lot of space. It's an older system with older technology. So when I coordinate frequencies for this BTR-800 system in the E88 band, right out of the box, the standard number of frequencies I find is about 10 frequencies for the base station and 11 belt pack frequencies. Now, if I've got a small production, that might be more than enough and I could be good to go. But for larger coordinations or larger shows, I might need more than this number of frequencies. So if you're familiar with compatibility profiles, what I could choose to do is maybe select this more frequencies compatibility profile, which would change all of the channel to channel spacings and the channel to IMD spacings affiliated with this device. But when I do that, you see, I might not want to use a narrower channel-to-channel spacing. I might like the insulation of having frequencies further apart, and maybe this channel-to-two-tone third-order intermod, I don't want to reduce that value at all. Now, if you don't know what these terms mean, this channel-to-two-tone third-order intermod, you may want to learn a little bit more about what intermodulation products are before using this feature. But if you do, then I think this feature is going to make a little bit more sense. So these checkboxes, this whole tool panel we've added in the compatibility tab of Wireless Workbench, is a tool set that when you select the header of a type of frequencies you want to affect, these controls wake up. So what I can do with these checkboxes is basically choose to ignore or stop considering certain intermod products when coordinating frequencies. So why would I ignore certain intermod products? Well, this three-tone third-order intermod product is a product that's generated when three transmitters of this sort of system are in close proximity with one another. This is an intermod product that is the result of sort of close proximity transmitters resonating with one another, their frequencies resonating with one another. Now, if I know that my techs who are going to be wearing these belt packs and the location of these base stations are not close to one another, I can turn off these intermod products for three-tone third order just by unchecking this checkbox. And what that will do is it will inform the calculator to not worry about any three-tone third order intermods that may result from close frequencies and basically treat this value as if it were zero. So I can turn this off for system by system at a time, or if I had a bunch of systems, I could actually select them all and just turn this off wholesale. And you'll see when I turn off an intermod product for a particular type of system, this little badge, the 3T30 with a line through it, shows up, just to make sure that I don't forget that I've turned off these intermod considerations. So whereas I found 21 frequencies before, now if I turn off 3T30 consideration for these frequencies, already I found 37 frequencies, 18 or 19 apiece for each. Now, I didn't change in any way the channel-to-channel spacing or the channel-to two-tone third order or any of the other intermod spacings other than just ignore the three-tone third order intermods. And already there's a pretty dramatic result, almost double the frequencies I could find. And you can see the density of those bands is a lot higher. So the reason I say this is an advanced tool is using these intermod ignore capabilities in the wrong context, where transmit or receive entities can be really close in proximity to one another, could result in less than ideal performance. Now, I give the warning to say you should know what you are, what you're doing and where your transmitters are going to be before you use this this sort of feature. But this ability to turn off intermods, so to speak, is a common feature in other top-tier frequency coordination applications. So I just wanted to make sure you were aware that in Wireless Workbench you have this capability. But we always like to make sure things work no matter what, which is why I give the public service announcement beforehand. So if you have any questions about how this feature works, or want to talk more about the applications of where to use it, please feel free to leave a comment down below. And if you'd like to see more tutorials on this topic, make sure you mention that as well. Thanks.